Okay, lecture 16, the last of the these equilibrium concentration problems for the chapter. All right, now let's read it through. Consider the reaction given here takes place at 898 Kelvin. 2-liter vessel contains 3.15 moles of CO and 1.77 moles of water vapor at the beginning of the reaction. How many moles of each species are present at equilibrium? So we have to determine equilibrium. They give us Kc, it's 307. So that tells us that we're going to have to be solving for x. We're going to have to solve for, we're going to have to use the ice table. And even if it doesn't tell you that, I mean, you're not at the point where you see that, you know it's Kc, you know the Kc expression is going to be involved. Most likely the ice table. Might as well try filling it in to see. And we have 3.15 moles of CO for a 2-liter vessel. That's going to give us 1.58 molar for CO, the CO concentration. 1.77 moles of water in a 2-liter vessel. So 1.77 divided by 2, this is 0.885. These are 0. Minus x, plus x, plus x. Because they're all 1 to 1. 1, 1, 1, and 1, so just x is involved here. Note the starting concentrations for CO and water are different. The last couple of problems we did, they were the same, and we were allowed to do that square root trick, or maneuver, sorry. Now we can't do that. If we put this into these values into the Kc expression, we'll see that the square root, or using the square root operation, is not going to help us, and Kc is 307. So if we took square root of both sides, we can certainly do it. That's certainly allowed to do, but it won't help us. So what we have to do is expand this out, and what we need to, oops, I'm sorry again. We're going to expand this out. We see that we have an x squared term, and what we need is to get it into this form. ax squared plus bx plus c is equal to 0. Then we can use the quadratic formula on this. I'm not going to write it here. We'll be using it, but that's our only recourse now. We don't have any way of getting rid of that x squared term, so we're going to have to solve the quadratic. We're going to have to use the quadratic formula. So I cheated a little bit. I did this out already. I did each of these steps. And the reason I did, this is the big difference between teaching it on video and in class. In class, I can take a while to kind of figure this stuff out. You're going to be pretty irritated if I take all this, if I sit here with my calculator working this out. So I'll just put in the steps. So expand this term out into this form. Then I multiply both sides by this term. So we get x squared left over here minus 758x plus 307x squared. Subtract x squared from both sides. We get this. And then I just swing it around so that it looks like this. It has this form. And now, so A is 306, sorry. 306. B is minus 758, and C is 430. So, and sorry for keep falling off the page there, but this is going to happen. Some of these problems may take 2 or 3 sheets of paper. That's just how it has to be. Very, very tricky to do these lectures on video. Now, so we know what A is, and now here's the A, B, and C. We know what those terms are. And the quadratic formula is x is equal to negative b plus or minus b squared minus 4ac over 2a. You need to remember that. Quadratic formula, very important. Then we put our values in. And we have, you see, it's plus or minus. So x, there's going to be two answers for x. Mathematically, both of them will be correct. But physically, in the real life situation, we can only have one of them make sense. The other one should be an absurd answer, as we'll see in a second here. Okay, get to this point. Yeah, and oops. So we put this in. So x is equal to 756 plus 7 minus 756 squared minus 4305 minus, and then what did I pick as where did I put that? Oh, there it is, 430. And over 2 times 306. The other answer for x, so it's a polynomial that contains x squared, so there are going to be two answers. If it's x to the third, if that term was present in the polynomial, then it would have three answers. And that can happen. Won't happen for us. But no matter how many answers there are, only one will be physically make sense. And if you're not sure what I mean by that, hold on, we're almost there. So we have, you can see the difference here. Everything's the same except that plus and minus. So these are our two answers. And so x, we find, is 1.59 molar, or x is 0.883 molar. We got those two answers, and I have them listed in a strange way on this paper, so I'm not sure which one is which, but you should find when you do these out, you have these two values. Now, which one is allowed and which one isn't? Well, if we go back to our original problem here, we have 1.58 minus x and 0.885 minus x. So x is either 1.59 or 0.883. If we put 1.59 here, we'd end up with a negative concentration, and a negative concentration here. Well, we can't have a negative concentration. We don't know what that means. We have to have a positive concentration. So just putting in this first term, we see that we'd get a nonsensical answer. We'd get a negative concentration. So, but this 0.883 fits the bill. So the concentration of CO, we just put them back into that original equation. We had this term, and I think I worked it through. This is going to be 0.697 molar, and then H2O is going to be 0.885 minus 0.883. Now, this is going to come close to being 0, but it's still larger. It just means that most of it was used up. And then the concentration of CO2 and H2, those were just equal to x, and x we found to be 0.883 molar. Those are the concentrations. Now I wanted I think the original was how many moles. So to find the moles of CO, which normally you don't have to do, I just wanted to mix it up and give you something new here. Or just so that you can find both. Usually you'll find the concentrations, but if they ask you to find the moles, no problem. Just take your concentrations and multiply by your volume. So this is going to be 2 times 10 to the minus 3 moles per liter times 2 liters, and then moles of CO will equal moles of hydrogen, and that's 0.883 moles per liter times 2. So the next one we only do the concentrations, but it's good to be able to go that extra step if necessary. And then we have 2 times 10 to the minus 3, so that would be 4 times 10 to the minus 3 moles. And then 0.883 times 2, so those would be 1.77 moles. And that is the end of that problem. Let's try this one. Going to be the same kind of thing. Going to go a little bit faster, just so we can make it onto the under the 20-minute mark. So here's our equation. We put in the concentrations. We have 4.1 moles of fluorine divided by 3.35 liters. That's going to give us 1.22 molar. Chlorine, we will find, is this. Minus x plus 2x. That's the deal. Don't forget that. We're looking for the concentrations, so we put them into, right now x is just an unknown, but if we put it into the Kc expression, and Kc is 1.97, now it's something that we can solve for. And so I'm going to expand this out for x squared over 0.932 minus 1.98x, x squared. I was tempted to just go this fast and act as if I'm just doing this in my head. So see how easy it is? Well, you know, you're going to have to use your calculator. It'll take, if I did it with my calculator right now, it'd probably take 2 or 3 minutes longer. It's not like it would take hours longer, but I just wanted to move quickly here. So rearranging, get this, and I can just put it into this form, just shifting things around. And that, now we have it in the form of ax squared plus bx plus c equals 0. Now, some people, I don't know if I mentioned this before, but when I've done this on the board, this flipping around, some people say, well, this would be plus and minus, because you'd have to add 2.03 to the 2.03 to this to move it to this side. Even if you did that, you could then just come through with -1 to get it back into this form. What I did was I just put the 0 on the other side. If 0 is equal to this, then this is definitely equal to 0, and then just rearrange the equation. But anyway, just the manipulations are there. And then you might not be comfortable with having minus 2.03 in front of the x squared. Then just divide through by negative 2.03. Then you'd have x squared, and then you change those numbers. You're going to end up with the same value. Doesn't matter what you do, as long as you keep, as long as you multiply it through by the same number. You can multiply this whole thing through, both sides, by 17,000, and then do out the problem. You'll get the same answer. Have to. So, but I'll leave it like this. So A is this, B is minus 3.91, C is 1.84. And then we use the quadratic formula. And I'm just going to do it right off the board here. We have this, and then we have minus 3.91 squared minus 4. Now, I should say that as I'm doing this, let me just make sure I got the right numbers here. As I go along, some of these steps I'm rounding when I wouldn't normally round. Because I want to show you every single step. And what that means is that your rounding is going to be, your answer might be slightly off from mine. Just because to show you what I'm doing, I'm doing, and I might have mentioned this before, but I might round, just go instead of skipping over steps and just multiplying 2 or 3 things together, I might multiply 2 things, round, then another 2 things, and round. So we might be slightly off, so just keep that in mind. Now, when you solve for this x, there's 2 answers here, plus and minus. So this is minus 2.32 molar, or x is 0.391. Now the 2 things here, you can only have only one of these answers can make sense. So if both of your answers fit into your equation, then you've done something wrong. Second thing is, if one of your answers comes up negative, immediately cross that off. That's the one that won't work. The other one has to. So let's make sure that it does. Looking back here, it's 0.39. So 1.22 minus 0.391 is definitely positive. 0.764 minus 0.391 is positive. 2 times that is positive, so perfect. So it's really nice when you get a negative number, and then you can just cross it off immediately because that doesn't make physical sense. Mathematically, it's fine, nothing wrong there. And I won't go into it here, but there's a when I talked with a mathematician about that, I said, well, why is this allowed? He went into, well, I'll just say, he said, the reason that this one is allowed is because we haven't restricted the problem further. If we wanted to make a really tight restriction on the equations, we could get rid of one of these terms before we even start the problem. But it makes it very tough because we're not sure what the restrictions should be. So instead, we just take a more general equation, get 2 answers, one of them is nonsensical, and then the other one has to work. So since we know the correct answer is going to be among the answers we get out, and it's going to be the one and only one correct answer, why try to restrict the equation before we even begin? So you say, well, why do we keep having to get rid of nonsensical equations? It just makes our life easier not to have to worry about reducing that equation before we even start the problem. It'd be very hard to do as well. Okay, so just an aside. So so the concentration of fluorine, 1.2 minus 0. And we get, oh, I guess I'm just going to have to do this out because I've lost my notes. That's fine. I'm not going to faint or anything just because I've done that. I got through the tougher stuff more quickly, and that was all I needed. So 0.764 minus 0.319, and then the concentration of the chlorine monofluoride is going to be 2 times 0.391. So 0.391 times 2, so 0.782 molar. And because we were just finding the concentrations, that's as far as we have to go.